so let's go over number or letter K from the worksheet. So this is letter K. See if some people can help me with this one. So we have limit as x goes to 0. We have 1 over 3 plus x minus 1 over 3 minus x all over x. Okay, so anybody have an idea how to simplify? This is called the complex fractions. It comes with a rational function category. So in integrated 3, you learned a lesson on rational functions, how to find horizontal asymptote line and vertical asymptote line. Within that section, we're supposed to kind of go over complicated fractions, which this is it, okay? Anybody have an idea what to do? How do we simplify this fraction? We want to start with the top. How do I combine these two fractions on the top? Anybody have an idea? We need to have a common denominator. What will be the common denominator? I need to multiply this fraction by 3 minus x and 3 minus x. And I need to multiply this one by 3 plus x and then 3 plus x. That's what you need to do. All right? So let's see. The top, we have 3 minus x over 3 minus x times 3 plus x minus parentheses. On the top, we have 3 plus x all over 3 minus x and then 3 plus x. It doesn't matter which order you put them in, but I want to put them in the same order. All over x. Okay, once you have a common denominator, what do you do with these two fractions? Anybody have an idea what to do with those two fractions when you have a common denominator? You add them together or subtract them. In this case, we're going to subtract, so I'm going to multiply by the negative. Does that make sense? So you can combine the numerator together. So this is limit x goes to 0. What do we have? We have 3 minus x minus 3 minus x all over. Do not multiply the denominator. 3 minus x and 3 plus x all over what? Isn't it x? Okay, so what happens on the numerator? What can we cancel anything in the numerator? Can I combine anything on the numerator part? Yeah, 3's cancel out. So 3's will cancel out. What about the x's? Yeah, negative 2x over 3 minus x times 3 plus x all over x. All right? So I'm going to give you a hint. Do you see this x in the denominator? This can be written as x over 1. Why would I want to put it as x over 1? Anybody have an idea why I put x over 1? Yeah, you can multiply by the reciprocal, right? So then now we have limit x goes to 0, negative 2x over 3 minus x, 3 plus x times 1 over x. Okay, so was it important to multiply by the reciprocal? What happens when you multiply by the reciprocal? X's cancel out, right? So what do we have left? Is when we have limit x goes to 0, negative 2 over 3 minus x, and then 3 plus x. All right, now, what was the whole purpose of doing all this work? Again, like in the beginning, this was our original problem. Do you see this original problem? Can I use direct substitution for this original problem? Can we use direct substitution for this one? Why not? You get a 0 in the denominator, which means undefined. So we needed to simplify by multiplying by, like common denominator and all that stuff, and multiply by the reciprocal. And we canceled out the x. Now we have this. Is it possible to use direct substitution for that part?
Yes.
Yeah, so what number do you plug in?
0.
0 and 0, so what is it if you plug in 0? This is negative 2 over 3 times 3, which is negative 2 over 9. That would be your... Okay, these are all like skills that you need to develop. You will, okay? You will learn these skills. Even if you haven't learned it in other class, you need to for this particular class. So I want you to go home and study it tonight and tomorrow and be ready on Wednesday. All right. Do you want to see something else or?
You do 3D.
Yeah, I can do 3D. So 3D. A, B, C, D. Is that it right here? This one? Yeah. Okay, this one is 3 and letter D. Looks like, let's zoom in. Right, so it looks like limit as x goes to negative 2, and we have x to the 4th plus 5x to the 3rd plus 6x squared all over x squared, x plus 1, 4, x plus 1. All right, now it looks very complicated, but all right, so first of all, you need to ask yourself, are we allowed to use direct substitution? Can we use direct substitution?
No.
What happens if you plug in direct substitution, right? Don't you get a 0? So that's no good. So no direct substitution right now. All right, so we need to use something else. So what do you think? Anybody have an idea what method will we use to kind of solve for this limit? What would you do? Anybody have an idea? Factoring. I like factoring. So it looks very complicated, but factoring is pretty easy for this particular problem. Do you see anything that I can factor from the top? X squared. And what else do you have left? X squared plus 5x plus 6 all over. This one is factoring by grouping. We went over grouping. Do you remember? Like in the beginning of the week. So what do you have in common from the denominator?
X plus 1.
Yeah, so you can factor out by grouping x plus 1. What do you have left over if you factor out x plus 1 and x plus 1?
X squared minus 4.
X squared minus 4. All right, do you notice anything else? Can we factor more? Is it possible to factor more?
Yeah.
Yes. How do we factor the numerator, top? What is it if you factor the top? X plus 3 and x plus 2. Isn't that pretty easy? I mean, it looked complicated, but it wasn't that bad to factor that, right? Wasn't it? All right, do you notice anything in the denominator? Is there anything that I can factor?
Yes.
Yes, this one. What is this?
X plus 2.
That's a difference of 2 squared, x plus 2 and x minus 2. All right, can you see anything that we can cancel?
Yes.
This one and that one. Now can we use direct substitution?
Yes.
Okay, I'll let you finish that on your own, okay? So more questions you guys have, make sure you come by after school. I'll be here. All right, or you can ask me tomorrow. We have an extra day. Okay? And I'll post this.